Good afternoon. I am Professor Naveen Chetty, the College Dean of Teaching and Learning. On behalf of the Vice Chancellor and Principal, Professor Nana Poku, it gives me great pleasure to welcome you to the inaugural lecture of Professor Aneshkumar Maharaj. The Vice Chancellor conveys his congratulations and best wishes to Professor Aneshkumar Maharaj. The Acting Deputy Vice Chancellor, Professor Fatu Mudau, conveys his apologies for not being here today, but congratulates Professor Maharaj on his promotion and thanks him for his contributions to the School of Mathematics, Statistics, and Computer Science. Inaugural lectures form part of the university's public lecture series and may only be presented by newly appointed full professors who have been appointed in academic schools and centers. Inaugural lectures present an opportunity for showcasing the exciting and groundbreaking research and teaching being carried out by professors in our university. Each lecture represents a significant milestone in an academic's career, providing official recognition of their promotion or appointment to full professorship. These lectures are furthermore an ideal opportunity for new professors to introduce themselves and to present an overview of their own contribution to their field to academic peers, students, and research collaborators. Inaugural lectures are also a platform for celebrating a professor's academic achievements with his or her family, friends, mentors, and colleagues. I would like to acknowledge the following guests this afternoon: members of the university's executive management, members of council, members of Senate, our inaugurant this afternoon, Professor Maharaj, family and friends of Professor Maharaj, our academics and professional staff, students, alumni, and distinguished guests. A special welcome to our guests from universities and organizations in South Africa, the African continent, and across the globe. Distinguished guests, it is my pleasure to introduce our Dean and Head of School of Mathematics, Statistics, and Computer Science, Professor Celestina Viriri, who will now formally introduce the inaugurant, Professor Aneshkumar Maharaj.
The Dean of Teaching and Learning, Professor Naveen Chetty, the University Executive Management, Council members and Senate members present here, the Registrar, and the staff within the Registrar's office, colleagues from the School of Mathematics, Statistics, and Computer Science, colleagues from the College of Agriculture, Engineering, and Science, colleagues from the university at large, the students present here, Professor Maharaj's family and friends, all invited guests abroad and locally, all protocols observed. Professor Anesh Maharaj is a full professor in the discipline of mathematics in the College of Agriculture, Engineering, and Science at the University of KwaZulu-Natal, Durban, South Africa. Professor Maharaj received his Bachelor of Pedagogics degree with distinctions in mathematics from the University of Durban, Westville in 1983. He obtained his honors, master's, and PhD degrees in 1991, 1998, and 2006, respectively, from the University of South Africa, UNISA. Professor Maharaj joined the School of Mathematical Sciences at the University of Natal at Howard College in January 2003 as a mathematics senior tutor and ascended to lecturer in 2008, senior lecturer in 2015, associate professor in 2018, and full professor on 1st of October 2021, all at the University of KwaZulu-Natal in the School of Mathematics, Statistics, and Computer Science. Professor Maharaj's research interests focus on the teaching and learning of mathematics topics, concepts, using APOS theory, which is the use of technology and to promote the teaching and learning of mathematics. He has successfully completed the supervision of 7 doctoral and 4 master students and mentored several NRIF interns and research assistants and published over 56 research articles in accredited journals. He currently supervises 5 doctoral students and a master's student. Professor Maharaj has examined several master's and PhD theses, for example, from the University of the Free State and the University of the Western Cape. He was a reviewer of several national and international journals like the Pythagoras, South African Journal of Science Education, African Journal of Research in Mathematics, Science and Technology Education, Journal of Mathematical Behavior. Professor Maharaj has been an invited speaker at several international conferences and workshops in India, China, Brazil, United States of America, Mexico, South Africa, among others. He has had the opportunity of giving invited talks in several universities such as Rhodes University, University of Zululand, Nagapa University, Homi Bhabha Center for Science Education, Tata Institute for Social Science, Coleman University, Graphic Era University, Amirite University, Chandgar University, and SVV. He was a visiting researcher to national and international universities and colleges from 2008 to 2022. Professor Maharaj is a National Research Foundation NRF South Africa C3 rated scientist, valid from 2022 to 2027. He was the recipient of several awards and grants, for example, the 2014 Distinguished Teacher Award at UKZN, and also awarded in 2015 by the Council of Higher Education, the Higher Education Learning and Teaching Association of South Africa, which is what is called the CHE Helter SA National Excellence in Teaching Commendation, the HP Catalyst Awards to attend the Global Summit from 2011 to 2013, NRF grants to research the development of e-learning and assessments at UKZN between 2014 to 2016 and also in 2023. He has developed many international collaborations as an associate member of the Multiversity Consortium of the HP Global Catalyst Education Summit. Colleagues, I invite the inaugurant, Professor Aneshkumar Maharaj, to deliver his lecture.
Good afternoon, everyone. So, sorry for slight hiccup. Reflections on my research journey at UKZN. It is my pleasure to present this public lecture. The overview of my presentation. My contribution is on the teaching and learning of mathematics at university level. The focus of this talk will be on the following: first year teaching context at UKZN, some insights into the teaching and learning of mathematics, organization and conducting of mathematics tutorials, insights from the HP Global Catalyst from 2010 to 2013, the UKZN ESCOM Mathematics Project, NRF Grant, Education Research in South Africa, 2014 to 2016, support structures for the teaching and learning of mathematics, APOS theory, 2008 onwards, master's and postgraduate supervision, The first year teaching context at UKZN, if you look at the photograph, our first year classes are usually huge. This is one of the first year classes that you see. If you look at the back, there are entrances on the left and on the right. You'll find there are students, there's students standing over there. And also if you look along the aisles, there are students sitting along the aisles. And if you look at the middle of the photograph, you'll see there's an entrance and there are students, there's students standing over there, the other students sitting, right? This is during a lecture. You'll see their students are engaged. So that's the teaching context. The classes are relatively huge. You're looking at about 250 to about 500 students in the lecture venues. Some insights into the teaching and learning of mathematics, right? What follows is based on the paper I wrote on using a task analysis approach within a guided problem-solving model to design mathematical learning activities. If you look at figure 1, a guided problem-solving teaching model, there are 3 phases. And these could be used to design learning activities. The inductive reasoning phase focuses on constructing a concept, discovering a relationship. The important thing is when one designs activities, there should be a willingness to try and appreciation on the part of the student. So it needs to be designed so that students feel comfortable to work with that activity. The inductive and deductive reasoning phase, this focuses on simple knowledge, comprehension, knowledge of a process. And the third phase is deductive reasoning. Now, if you look at the double arrowheads, they indicate that these 3 phases are interlinked. The deductive reasoning phase focuses on application and solving problems. That is what we aim for when teaching mathematics, if it is a service module. Again, there should be a willingness to try and appreciation on the part of students. So it's important that when designing the activities, one takes these into consideration. Simple knowledge, this involves the recalling of specific responses, not a multi-step process, to a specific stimuli. Here, learning activities should target the end product, namely the correct statement of the simple knowledge. For example, you look at example 1, state the standard form of the quadratic equation. Comprehension, this focuses on extracting and interpreting meaning from symbolic representations. And mathematics is a symbolic language and symbolic notation is used. So it's important that students are able to extract and interpret the meaning of the representations. Example 2, what do the following mean to you? A, we've got x into x plus 1 is equal to 12. So basically, it's the product of 2 numbers, x and x plus 1 is equal to 12. B, A, B is equal to 0. That implies A is equal to 0 or B is equal to 0. So it's a product of 2 numbers is equal to 0. That's a 0 product. That implies that one of the numbers should be 0. Knowledge of a process, engaging in an algorithm or multi-step process. Here, learning activities should aim to help learners achieve algorithmic skills. Example 3, outline the procedure to show that the equation cos x is equal to x has at least one root in the interval between 0 and 1. Example 4, outline the procedure to show that the equation cos x is equal to x has exactly one root in the interval between 0 and 1. Okay, the next part of the insights is based on the paper that I wrote, some insights from research literature for teaching and learning mathematics. The first point to note over here is a student's inability to acquire an in-depth sense of the structural aspects of algebra is a major obstacle. Example 5, x multiplied by x plus 1 is equal to 12 implies that x is equal to 12 or x plus 1 is equal to 12. Now this here is a common mistake that students make. It's a false generalization stemming from the zero product principle. The development of algebraic thinking is a sequence of ever more advanced transitions from operational, it's procedural, to structural outlooks. Example 6 illustrates that what type of an equation is x into x plus 1 is equal to 12. Explain your reasoning. The next point coming from Mason, the style and the nature of questions encountered by students strongly influences the sense that they make of the subject matter. Example 7, explain in words the information summarized by the following rule for differentiation. Now, you can see that this is the product rule for differentiation. It indicates to us if you are looking at the derivative of the product of two functions, then the derivative is found by leaving the first function as it is, multiplying by the derivative of the second function, adding that to the derivative of the first function, multiplied by, you leave the second function as it is. The organization and conducting of mathematics tutorials. Right, the information comes from the paper that I wrote on some findings on the design and implementation of mathematics tutorials at a university. The focus of that study was on the design and effectiveness of 4 tutorial types in the context of first-year mathematics tutorials. A model was designed, a model for the design of mathematics tutorials was formulated. That model informed the design, implementation, and refining of the mathematics tutorials over a 9-year period. It was found that students get greater benefit from tutorials that are more organized. I think that's reasonable. And it's common sense. But the tutorials should include a completion of homework unit requirement. That part is important. Now, the model that was designed for mathematics tutorials, right, it's just influenced by APOS theory, which makes assumptions on learning and on mathematical knowledge. Now, APOS theory recommends the ACE teaching style. ACE represents activities, classroom discussion, exercises. And in the context in which I function, the exercises were really homework problems for tutorials. Right? So the teaching took place, there were classroom activities, classroom discussion, and then exercises that fed into the tutorials. Now, the design of tutorials, the tutorial should be designed so that the students get the most out of the tutorials. Also, certain tutoring skills are required. It means, implies that one should train the tutors. The tutoring skills for the students, if you look at the dotted line going down, the arrow, the student should acquire certain skills and learning techniques. The participation of the student is important. And the quality of that participation will determine either success or failure. Now, if you look at the blue boundary, right, that encompasses the ACE teaching cycle, the tutorials, and so on, the whole thing is overseen by online material and the use of technology. This is an example of students working in groups during a mathematics tutorial. See, the students are engaged. There are tutors that are assisting them. These students are put into groups where tutors oversee groups of students. Now, the examination results of some first semester modules. The first column deals with the final results. You'll see that there's number passed, number wrote, and the class average. The 4 types of tutorials going across in the first row, less organized. This was in 2003 for Math C. Then you look at the class average was around 54%. The pass rate was around 62%. Right, by less organized at that stage when I just got to the university, this was a very large group of students. We had about close to 1,000 students doing the module in 3 different timetable blocks. And for the tutorials, the tutors used to stand in the front, and the students used to go to the tutors to seek help. So during the lectures, I impressed on the students that they should attempt the tutorials before coming to seek help from the tutor. So the pass rate, I think if one looks at the circumstances of the percentage being 62% there, it wasn't bad. Then somewhere in 2005, one of my students indicated that he thought that if I put students into tutorial groups, the impact will be better. So I started organizing the the students into tutorial groups. So it's organized large groups in 2006. This was for Maths 134. Right, you look at the pass rate there was 73%, around 73%. So you can see that there is a difference there. It's basically the same course. Maths during the merger, Maths C actually became Maths 134. Right, it's the quantitative methods course. Organized large groups. This is in 2007. Again, for Maths 134, you'll see that the pass rate was around 82%. Then organized large groups for Maths 133. This is now what we call the Maths for the Natural Sciences. It's more or less that module. The pass rate was around close on to 74%. Right, so those were the first semester modules. Then in the second semester, if we looked at the modules, right, this is before the merger in 2004, Maths 1S2. After the merger, that became Maths 140. So you can see that the pass rate in 2004 was around 73%, which was very good. Now here, if you look at the organized with tutorial tests in 2008, the pass rate is just below 60%. And that was puzzling because we put in a lot of work for that module. The next year, we looked at, it's the same organized large groups for the same module, Maths 140. But we didn't have tutorial tests, but we gave credits for completion of tutorials. Right, and you can see that the pass rate increased to 73%. Then organized smaller groups. Right, this was in 2010 for Maths 145. That's further topics in mathematics. Right, the pass rate was around 82%, and you can see the class average is around 62%. Now, organized smaller groups. The students again were in small groups, but the class size was relatively smaller than the class size for Maths 140. So it was possible to give students a mark out of 10 for each tutorial. And this slide indicates the scoring criteria for each homework unit. All right. So you can see the first point, neat and orderly presentation of work, 1 mark. Now, some people may argue that this is not mathematics, but it's important for students to work in an orderly manner. 2, odd-numbered questions marked in pencil. For the odd-numbered questions, the textbook, the prescribed textbook, gives the final answer at the back of the book. So if students mark the work in pencil, they earn that 1 mark. Number 3, corrections, if any, done in pencil from the point of breakdown. Right, there's 1 mark, and this is linked to point 8. You'll see there's an asterisk over there. Number 4, student comes prepared for help with their attempts, 1 mark. Number 5, explanations given for working where possible. Right, I encourage students to give explanations whenever they're working out the solution of a problem, and that is illustrated during the classroom discussions. Number 6, the correctness of mathematics and reasoning, 2 marks. Number 7, 80% completion of homework, that's 2 marks. 8, interest and enthusiasm shown for tutorials, that's 2 marks. So, as I pointed out, points 3 and 8 are linked. The second point to note is that a student will be given as a mark of 0 if there's any evidence of dishonesty. For example, copying, indicating the work is correct when clearly it is otherwise. To obtain a score of more than 5, a student must satisfactorily answer questions posed by the tutor. Number 4, a score of less than 7 for the TUT indicates that the 80% of homework completed requirement was not satisfied. Right? Using this, we're able to get that 82% pass rate that I indicated in the previous slide. The HP Global Catalyst from 2010 to 2013. In August 2010, I was invited to be an associate member of the Multiversity Consortium for the HP Global Catalyst Initiative. In March 2011, I did a presentation at the HP Global Catalyst Summit in New Delhi, Maths for the Natural Sciences. In August 2011, funding was granted for the first phase of the Maths e-learning and assessment, a South African context, right? That was the project. And the photograph that you see, it's at the 2013 HP Catalyst Summit in Sao Paulo, Brazil, with members of the Multiversity Consortium. The HP Catalyst Multiversity Consortium, right, it began before 2010. You can see on the left-hand side, Sloan Consortium, that's in orange, right? The ideas came from there. Then in 2010, there were recipients of grants indicated in yellow, right? Mostly in North America. There's one in South America, one in Asia. Then you have in green the 2012 recipients, right? And you can see that Stellenbosch University got in over there, right? And then I was invited as an associate of the Multiversity Consortium. I was representing the University of KwaZulu-Natal, right? So the insights that I got from the HP Global Catalyst Summits that I attended from 2011 to 2013, the problem of underpreparedness of incoming students is universal. It's a universal problem in developed and also underdeveloping countries. The use of technology could be exploited to deal with this issue. MOOCs, massive open online courses, right? And these are available on the internet. The funding that was received for the Maths e-learning and assessment, a South African context project, for which I did the proposal, that sort of kickstarted things at UKZN. It set the groundwork required for pre-calculus knowledge and skills to study university mathematics. And a paper that came out of the work that we did was the paper that's indicated over there, designing website-based tasks to improve proficiency in mathematics, a case of basic algebra. Right, initially when we began with this project, we found that students coming to university to study mathematics could not add two fractions, simple fractions, say half and 1/3. There were 60% of the students were getting that calculation incorrect. The UKZN ESCOM mathematics project, this project focuses on concerns about the preparedness of students who arrive at university to engage with further studies in mathematics, right? It was found that most of the students are underprepared. The mathematical abilities of university students and graduates who seek employment with ESCOM and its customers. So this was another concern. According to the people from ESCOM, the university students and the graduates that they were getting from university did not have the necessary skills. There was a need to address those concerns at 3 levels. At a research level, to inform what needs to be done at the university and also in the schooling context, with the focus on improving the teaching and learning of mathematics, evaluating and continually improving the support to equip new students with the prerequisite knowledge and skills required for first-year mathematics, including engineering students. Devising support programs for grade 11 and 12 mathematics teachers and learners. This could require upgrading of teacher qualifications and abilities, and the provision of quality support material for both teachers and pupils. Right, the upgrading of teacher qualifications. The funding received for the project was used to provide bursaries for teachers selected by the subject advisors to do Maths 130 and Maths 140. Now, Maths 130 and Maths 140 are our core mainstream modules. All right, they are our gatekeeper modules for mathematics. Okay, this was the photograph that you see. That indicates the second intake of teachers for Maths 130 in July 2014. And what the research showed is that the teachers that did the Maths 130 and 140 modules were producing better results. This was the feedback from the subject advisors. Right. These are some of the papers that we wrote, right, for the work that was undertaken for the UKZN mathematics, UKZN ESCOM mathematics project. Right, the first one, a framework for the development of mathematical thinking with teacher trainees. The second one, pre-service teachers, understanding of continuity of functions in the context of assessment items. And the third paper, exploring support strategies for high school mathematics teachers from underachieving schools. Right, in the next set of papers, exploring pre-service teachers' mental constructions when solving problems involving infinite sets. And the last one, teachers' views on mathematics up to grade 7 and its teaching. Right, in the next two papers, an investigation into the preparedness of teachers to teach grade 12 mathematics, a case study. And the last paper over there, teachers' understanding of grade 12 mathematics content, a case study. The NRF grant, Education Research in South Africa, 2014 to 2016. Right, this grant was received for the project Online Diagnostics for Undergraduate Mathematics. The research papers, all right, much of the work for this was done during my first sabbatical during 2012 and 2013. Right, the first one with Vivek Wog from the Center for Scientific Learning in Nagpur, India, an outline of possible pre-course diagnostics for differential calculus. The next one, an outline of possible in-course diagnostics for functions. Next one, an outline of possible in-course diagnostics for elementary logic, limits, and continuity of a function. Next one, an outline of possible in-course diagnostics for derivatives and integrals of functions. So basically, the last three papers over there make up the content of Maths 130 and Maths 140, our gatekeeper first year mathematics modules. Those papers led to the development and rollout of websites for online assessments. Right, and these are the websites: Diagnostics for Pre-Calculus, this was from 2014 onwards; In-Course Diagnostics for Undergraduate Mathematics, Maths 130 from 2015 onwards; In-Course Diagnostics for Undergraduate Mathematics, Maths 140 from 2015 onwards. Right, every year those websites undergo improvement. Now, some of the research papers based on the data generated from those websites are as follows: students' ability to correctly apply differentiation rules to structurally different functions. Students' difficulties in solving matrices, a case study. Right, in the paper that was written last year, in the context of COVID, students' experiences on the remote teaching and learning of linear algebra during COVID-19. Support structures for the teaching and learning of mathematics. Right, this paper was written again with Vivek Wag from the Center for Scientific Learning in India. Reflections on support structures available to first-year mathematics students at a university. This focused on the support structures for first-year mathematics students at UKZN. The objective was to determine the effectiveness of support and communication to students. The literature review focused on support structures offered to students at universities in other countries. Data was obtained from the UKZN module websites, responses from academics, academic staff, and also students. It was found that the support structures offered at UKZN compared favorably with those offered by universities in other countries. It was also found that there was a need and a scope to improve on the effectiveness of student support structures that are provided for first-year mathematics. These involve policy, right, at the school level, and also administrative and academic issues. APOS theory, 2008 onwards. Right, this is Ed Dubinsky, is regarded as the father of APOS theory. I had the pleasure of meeting him in Monterrey, Mexico. And in 2010, he came down to Durban for the SAMSTER conference. And I had a lot of interactions with him regarding APOS theory. Right, Ed Dubinsky, unfortunately, he passed away last year. I think to note is that Ed Dubinsky was a mathematician. So the theory that he formulated, APOS theory, came from a mathematician, right? It's unlike other theories where in mathematics education. So what is APOS? APOS refers to mental structures, right? Action, process, object, schema. These mental constructions take place in the student's mind, right? And if you're interested in that, there are examples in the papers that I authored or co-authored. The ACE teaching cycle, I've explained that earlier. I think in the South African context, the ACE teaching cycle applies very easily, right? Activities, classroom discussions, and exercises. So it fits in. In the States, when they used the ACE teaching cycle, it was based on the use of technology, the students' use of technology. The research papers that resulted, right? This was in 2010, the first paper that I wrote on my own on APOS, right? An APOS analysis of students' understanding of the concept of a limit of a function. The next one, an APOS analysis of natural science students' understanding of derivatives. Right, this is with one of my students, the next paper, and one of my collaborators. Schema development for the chain rule, a South African case study. The next one, an APOS analysis of natural science students' understanding of integration. Right, and the next one is a framework to gauge mathematical understanding, a case study on linear algebra concepts. Right, this is one of the most widely read papers that I wrote. The last count from ResearchGate indicated there were 8,000 reads for this paper. This paper has also been cited a number of times. Now, the framework that I formulated for this paper to gauge mathematical understanding. So a framework to access mathematical understanding. Right, in the first column, we've got the literature source and the depth. The second column deals with mathematical understanding. Third column, the APOS mental structures. Right, mathematical understanding could be instrumental or relational. Instrumental, where a student just does things without actual understanding. That's at most at an action level, according to the APOS mental structures. Relational understanding, it's connected to an existing network, process, object, schema. The number and the strength of connections is important. There are connections between existing schema, that's if you relate it to APOS. Then mathematical symbolism. All right, looking at the work of Godino, Ebert, and Carpenter, and so on. Mathematical symbolism could serve two purposes: an instrumental role. And if one looks at the right-hand side, this deals with interactions among mental structures of actions, processes, objects, and schema. Right? In the instrumental role for mathematical symbolism, an individual uses the symbolism to keep track of his or her thinking. Right? Then mathematical symbolism could also serve a communicative function. where the solution of a problem is written down and it's communicated to others. So this requires an execution of mental structures, and there's external evidence where someone could evaluate the solution, right? And if you look at the next row, it's logically organized conceptual system. That's where we want to get finally when we're teaching mathematics, the degree of development and interrelationships of schema, within schema and between schemata, right? So the degree of development and interrelationships should increase. Some APOS research papers with postgraduate students, right? I'm just going to run through these. Postgraduate supervision, some master's graduated students and topics, right? The first one, integration of mobile technology in the teaching and learning of mathematics at the further education and training phase. Next one, an APOS theory approach to students' understanding of concepts in linear algebra. Some of the PhD graduated students and topics, right? The first one, an APOS exploration of conceptual understanding of the chain rule in calculus by first-year engineering students. The next one, an exploration of the design and development of a semi-integrated curriculum for a mathematical literacy course offered in a B.Ed program at a South African university. The next one, exploring in-service Zimbabwean mathematics teachers' preparedness to incorporate ethnomathematics approaches to geometry teaching and learning. Right, the next one, an investigation of secondary school mathematics teachers' knowledge and utilization of their students' learning styles. Exploring university students' mental constructions of the limit concept in relation to sequences and series. An APOS analysis of the development of cognitive constructions for local maximum/minimum in grade 12 calculus. Investigation of the South African Public TVET College's engineering official mathematics curriculum for entry-level artisans. Some current PhD students and topics. Right, you can see that over there. The last one, there is an APOS analysis of undergraduate students' understanding of topology concepts. Some of my postgraduate students. Some of my collaborators, right? Professor Bridgedal, Vivek Wag, Ojan Narayan, and Gafari Lukman. My thanks to Professor Sunil Maharaj, Professor Kesh Govender, Mr. Logan Pillay from ESCOM, the late Sanjay Wag, Ravi Subramaniam, and Professor Abe Saxena. These are some of my family members who contributed to my success. Thank you.
Thank you, Professor Maharaj. Mathematics has always been challenging, and I think your talk inspired me to see just how challenging it is. I think we're in for a tough time at the school level, but your work is making great inroads. I must say that the APOS theory seem to fascinate me as a physicist. I certainly must read up more on that. So thank you very much for your talk and well done. Putting together an event like this takes a lot of work, and not least, I'd like to extend a vote of thanks to the school for accommodating you, Anesh, and for allowing you to develop as an academic to a full professor level. I'd like to thank you again for the effort you put into this presentation today. And ICS Registrar's Office. Apologies, Prof. Yuri, am I audible?
Yes, you are, although breaking up a bit.
I cut off. How far should I think I'll just start again, just in case. Oh, okay. Thank you. So I'd like to just again say thank you to Professor Maharaj for the enlightening talk. It really helped us understand mathematics education in a little more detail. To the school for accommodating him and allowing him to grow as an academic and to get to a professor level. He really has shown great achievement in doing so. Putting together an event like this requires a lot of hard work, and I'd like to thank our Corporate Relations Division, our ICS, and the Registrar's Office for putting together these events, which are so informative and so valuable for academics, the family, and also for the greater guests throughout the country as well as overseas. And I'd like to thank you as the guests for attending. Your time and effort in listening to this presentation has really helped and will help Professor Maharaj grow further. So thank you all very much and have a great afternoon further.